All right, so in this video, we're going to go through sample question 94 from the Society of Actuaries ExamP list of sample questions. Right. Let T1 be the time between a car accident and reporting a claim to the insurance company. Let T2 be the time between the report of the claim and the payment of the claim. The joint density of T1 and T2, F of T1, T2, is constant over the region 0 to T1 to 6, 0 to T2 to 6, and T1 plus T2 less than 10, 0 otherwise. We want to calculate the expected value of T1 plus T2, the expected time between a car accident and the payment of the claim. Okay, so first thing is, in order to get anything related to the expected value, we actually need to know what the joint density function is. Notice it doesn't actually tell us. Drawing a picture with questions involving joint density always going to help out. So let's draw out what this might look like. Here, this will be T2. This will be T1 here. Okay. And what are we told? We're told that T1 goes from 0 to 6. So this will be 0 all the way to 6 here. And T2 also goes from 0 to 6. So 0's here, 6 is up here. And we're also told the following. T1 plus T2 is less than 10. Now I'm going to rewrite that down here as T2 is less than 10 minus T1. Okay, great. And I'm going to want to graph this line. So it starts all the way from 10. I'm going to extend this line up here. That's the y-intercept. And it comes down to being 10 here. All right, so that's 10, and it's a line that's drawn down this way. Okay, and actually I'm going to move this 6 back here so it doesn't look too weird. This shape, the area that I'm kind of concerned with is from here to here, anything within this region, right? It's also important to know where these 2 points are, like what these 2 coordinate points are. And I can use the inequality to actually find that out. So this line, by the way, is the equation T2 is equal to 10 minus T1. If T1 were to be 6, this would be 4. So this is the coordinate point 6, 4. Right? That's 4 here. And likewise, if T2 were 6, T1 would be 4. So this is 4, 6. Okay. Now, in order to find the actual density function, our density function, because we're constant over the region, f of T1, T2 is equal to 1 over the area. Okay, so we want the area of this whole thing. The way we're actually going to get that is by splitting this up. We have kind of composite shapes. Square here, rectangle here, triangle here. So this is a 4 by 4 square. So I know that area is going to be 16. This is a 2 by 4, so that area is going to be 8. This is also a 2 by 4. That area is going to be 8. And this is a right triangle. That's 2 by 2. So 1/2 base times height should get me just 2. Okay, 32. So this is equal to 34. Right, 16 plus 8 plus 8 is 16. 16 times 2 is 32. Plus 2, 34. So I've now found that f of T1, t2 is equal to 1 over 34. And now I can actually go and figure out, and it's 0 elsewhere, right? Now I can actually go figure out the expected value. My expected value that I'm looking for is the following, t1 plus t2. Now, one thing I want you to notice about this graph is that it is symmetric, okay? If I were to switch my x's and y's, it would look the exact same, all the numbers would be in the exact same place. I can split this up. This is the expected value of t1 plus t2, expected value of t2. And again, because of symmetry, I'm able to write this as 2 times the expected value of t1, right? That way I only have to find one of these. So next step is to logically find one of these. So what I'm going to do is find the expected value, and I forgot the E here. That's very important. The expected value of t1, and then I'll just double it at the end, okay? So how can we find the expected value of t1? Well, we're going to set up an integral, right? So this is going to be equal to t1 multiplied by the probability, t1, t2. And that's going to require some integration. So one thing that we're going to now notice is we've kind of got a few different ranges for t2, right? So let me grab this guy here. From here to here, it goes from 0 to 6, right? From here to here, it goes from 0 up to this line, 10 minus t1, right? And because of that line just kind of cutting through, we're going to need to take two different integrals and add them together, right? Combine them. Well, 4 different integrals. We're going to need to do 2 double integrals, okay? So let's set that up, right? Our first set of integrals, I'm going to take the integrals with respect to dt2, dt1. So from here to here, and that's dt2, dt1. And dt2 goes from 0 to 6, and dt1 will go from 0 to 4, right? So I'm doing this section first, and I'm going to add this section, okay? So this is going to go from 0 to 6. This will go from 0 to 4. And I'm going to add on another set of integrals. And again, dt2, dt1. And that goes, dt2 goes from 0 all the way to this line, 10 minus t1. So 0 to 10 minus t1. Whereas here, for x, we're going from 4 to 6. So 4 to 6. And then I actually put in the thing I'm integrating my, the thing I'm going to integrate is 1 over 34. What was it? T1, right? And 1 over 34 T1 as well here. Now here's the thing. These are both constants right now because I'm integrating with respect to T2. So I'm going to, one, get another piece of paper, but I'm also going to kind of take those out. I'm going to move them to the front and rewrite this as integral from 0 to 4 of 1 over 34 T1, integral from 0 to 6 of just nothing, right? Just 1 dt2 dt1 plus 4 to 6, similar thing, 1 over 34 T1, integral 0, 10 minus T1 of 1 dt 2 dt1. So the integration is going to take a bit to just write out. Okay, so I'm going to make sure I'm in frame here, and I'll write this kind of the next line on the next page. All right, so we still have our outer integrals. So this is equal to 0 to 4, 1 over 34 t1. And this obviously should just be t2 and then evaluated from 0 to 6, right? Multiplied by, so t2 evaluated from 0 to 6 plus 4 to 6 of 1 over 34 t1 evaluated from and then t2 evaluated from 0 to 10 minus t1. Now, this is obviously just 6, right? So this is going to just be 0 to 4, 6 over 34 t1 plus integrating here 4 to 6, and this will just be 10 minus t1, right? So 1 over 34 t1 multiplied by 10 minus t1, and it might do us good to just kind of distribute that out. 0 to 4. And I'm actually going to simplify this, divide the top and bottom by 2, 3 over 17 t1 plus, integrate here, 4 to 6. 10 over 34, 5 over 17. T1 subtracted by 1 over 34 t1 squared. Okay, so this is what we have set up, and it's just a little more calculus. Okay, so this is going to become 3 over 34 t1 squared, and we're evaluating that from 0 to 4. Plus, this will be 5 over 34 t1 squared, 4 to 6. And subtracted by 34 times 2, that should be 68. Oh no, times 3, because it's a t1 squared. So use my handy calculator, just make sure I'm doing that right. 34 times 3, 102. So this is going to be subtracted by 1 over 102. T1 to the third, also evaluated from 4 to 6. And this can be just done in your calculator to get the next set of numbers. So I'll do that right now. Use your old TI 30X. Now, one thing I always say is I don't have these done out beforehand, usually, just because I think it's nice for you to see kind of the way I'm solving it, kind of the process you would go through on an actual exam. This is going to be 24 over 17 plus here 5/34 times 36 subtracted by 5/34 times 16. And I get 50/17 minus here 1 divided by 102. (76/51). And let's compute this. Right, sorry about that cut. Yes, so just adding this up, subtract here, and we are left with 146/51, which is approximately 2.86. Now that doesn't line up with one of our answer choices. Why not? Remember, we have to take this number, because this number is the expected value of T1. We're looking for this, which is 2 times the expected value of T1. So multiplying this by 2, we get approximately 5.72. Take this and I multiply by 2, I get approximately 5.72, which we know which answer choice that lines up with. Answer choice C. Okay, so just to quickly go over, everything we went through here. Decently difficult problem, multivariate distributions. What we did first was draw a picture. Anytime we're dealing with joint densities, draw a picture. That's going to help out loads. Okay. After we drew that picture, what we needed to do was then figure out, okay, what are we looking for? We need the actual PDF, right? So we figured that out, 1 over the area. And then once we did that, we went about setting the formula up to calculate expected value. And that's most of the, I would say, most of like the critical thinking part of it. The rest of it was just being able to do calculus, right? That's most of this. But yeah, that's pretty much it. If there are any questions, throw it down in the comments. I'll answer to the best of my abilities. If this video helped you out, hit the like button and subscribe. That totally helps me out. And if you want to see more videos like this, I got a playlist growing every day. More sample ExamP questions. Check it out. But other than that, thanks for watching. Hope this helped.